So welcome to our 21st Data Science Meetup. It's an event we organize every 2 or 3 months, and we try to bring together people dealing the topic of data science, machine learning, and statistics applied for business. And today's session is dedicated to the domain of insurance. And we have a lineup of three speakers, or three groups of speakers, I should say. First one from HEC Insurance, who would speak to us on how data could help us to manage flood and other natural calamities in a better way. Secondly, from We Group, we will hear from them about a customer journey towards how to automate the claims process. As we know, it's a very difficult and cumbersome process, so hopefully via their presentation we'll get some insights on how to automate and make it more streamlined. And finally, from KPMG, they will tell us how AI ecosystems can help us to reinvent or redesign insurance propositions. All right? So each talk would be for around 15 minutes, followed by question and answers for 5 minutes, so more or less 15 to 20 minutes per session. And then there will be a drink afterwards. I'm not sure what the drink is, but our colleague here will tell you what the drink is. I just came myself. But you should be at the drink. There would be some nice champagne, I think, or a nice beer and cheese and sandwiches for you. All right? Without waiting any further, I would now give the floor to our colleagues from HEC Insurance for their presentation, which I think will be in French.
Bonsoir, merci de nous avoir invités et pour l'organisation du Meetup. Probablement que je ne dois pas vous rappeler les événements qui ont eu lieu l'année passée, les inondations qui ont impacté à peu près 70 000 ménages répartis sur 209 communes. Donc ça a un gros impact pour un assureur comme HEC. Ça nécessite de répondre vite et de prendre des décisions qui sont data-driven. Et avec Mathilde, on va vous partager notre expérience sur cet événement et notamment comment on a utilisé les données pour aider à gérer cette crise chez HEC. Donc, on parle de 3 jours de drache nationale qui ont causé des dégâts immobiliers estimés à 2,2 milliards d'euros. 2,2 milliards d'euros, comment on arrive à ces estimations? Si on devait nous poser la question aujourd'hui, ce serait très simple en fait. Il suffirait de faire le coût total de tous les sinistres déclarés chez tous les assureurs. Sauf que la direction forcément n'allait pas attendre un an pour avoir ces réponses. Ils voulaient la réponse tout de suite. Et quand je dis tout de suite, ils voulaient déjà une estimation le soir même. Ouais. Et donc, pour les aider à gérer cette crise, ils avaient besoin de réponses à 3 questions. La première, c'est combien? Combien de sinistres allaient être déclarés? Et combien de sinistres les gestionnaires et les inspecteurs allaient-ils devoir gérer? Et surtout, est-ce qu'il fallait mobiliser des collaborateurs ou est-ce qu'il fallait engager de nouvelles ressources pour aider à gérer tout ça? Faut rappeler aussi qu'on était en juillet, donc c'était une période de vacances, et donc on était déjà avec des effectifs réduits. La deuxième question, c'est où? Quelles étaient les zones les plus impactées? Où fallait-il envoyer les inspecteurs en premier pour qu'ils puissent faire leur travail le plus vite possible et le plus efficacement possible, et aussi pour assurer une bonne expérience client? La troisième question, et ça c'est la plus importante, c'est combien est-ce que tout ça allait coûter? Et ça c'était la question la plus difficile. Et la grosse difficulté ici, c'est qu'on n'avait pas encore beaucoup d'informations à ce stade-ci. Et surtout, on savait qu'on n'allait pas pouvoir se baser sur le passé, sur les coûts historiques du passé, parce que forcément on n'avait encore jamais vu ce genre d'événement. Donc tout ça était nouveau. Mais avec Mathilde, on va vous montrer alors comment on a estimé ce coût total pour HEC. Donc, la première question, c'est combien de sinistres. Et en fait, c'est la seule partie pour laquelle on a quand même pu se baser sur des informations du passé, parce que pour des événements majeurs dans le passé, je parle d'inondations, mais aussi de tempêtes, de grêle ou d'autres événements climatiques, on avait déjà remarqué que les sinistres étaient souvent déclarés à la même vitesse. Ça veut dire que X jours après un événement, on sait qu'en général, on a telle proportion de sinistres déjà déclarés. Et donc, après quelques jours, on a pu déjà extrapoler et faire une estimation du volume des sinistres qui allaient arriver. Donc, sur la ligne en bleu clair, on voit l'évolution de notre estimation. Et on voit que les premiers jours, c'est encore un peu volatile, mais ça s'est assez vite stabilisé. Et la ligne bleue foncée, ça, c'est le volume réel déclaré. Et on voit que ces deux courbes convergent. Et ça montre donc que notre estimation était vraiment très proche de la réalité, et ce, après seulement quelques jours. Donc maintenant, on a une idée du volume total. L'étape suivante, c'est d'estimer les coûts moyens, et je vais laisser Mathilde vous expliquer ça.
Donc arrivé à ce stade, on avait besoin de la contribution des experts et des inspecteurs. Donc pour anticiper au mieux, pour anticiper le pire scénario, nous avions besoin que les experts aient évalué l'ampleur des dégâts sur le terrain. Mais avant d'envoyer nos experts sur place, pour qu'ils nous donnent leur feedback, on avait besoin de savoir où les envoyer en premier, savoir quelles régions étaient les plus impactées. Et donc la question principale est alors devenue comment identifier ces régions. Dans un premier temps, on a simplement lu, parcouru et écouté la presse, les news et les réseaux sociaux. Grâce à ça, on a pu identifier 40 codes postaux critiques et on a pu envoyer rapidement nos experts sur place pour qu'ils puissent commencer à travailler et nous transmettre un maximum d'informations le plus rapidement possible. Bien évidemment, on était conscient que ce n'était pas suffisant. Les informations dans la presse peuvent être biaisées ou incomplètes. Ça s'est prouvé aujourd'hui, car comme l'a mentionné Claudia, on n'est pas à 40 codes postaux, 40 régions impactées, mais déjà à plus de 200 municipalités impactées par cet événement. En parallèle, on a dû réfléchir à comment enrichir nos connaissances, et ce de manière plus granulaire. Et donc pour ça, on a sollicité les services publics de Wallonie, des voies hydrauliques. Donc sur le site du SPW, on peut retrouver pas mal d'informations concernant les hauteurs d'eau des rivières en Wallonie. Ce site, il est généralement utilisé par les autorités locales et les services d'aide en cas de montée des crues des rivières. Donc il s'agit d'une source d'information un peu plus objective et un peu plus fiable. Sur ce site, on peut retrouver la situation des cours d'eau au cours du temps. Et donc, comme on peut le voir sur le screenshot en haut, le 15 juillet après-midi, on pouvait déjà voir sur le SPW que la majorité de la Wallonie était en phase d'alerte d'inondation. Le SPW, il a à disposition plus d'une centaine de stations autour des rivières qui mesurent la hauteur des eaux plusieurs fois par jour. Et donc, pour chacune de ces stations de mesure, on a pu aller extraire la hauteur d'eau enregistrée à divers moments, ainsi que les coordonnées géographiques de ces stations. En tant qu'assureur, nous avons également pas mal de données internes, bien évidemment, dont notamment savoir quelles maisons, quels bâtiments sont couverts chez nous, les adresses, les coordonnées géographiques, et ainsi que l'objet de risque couvert. Donc, c'est-à-dire, est-ce qu'on couvre uniquement le bâtiment, est-ce qu'on couvre que le contenu, ou est-ce qu'on couvre les deux, bâtiment plus contenu. Donc, en combinant toutes ces données internes et externes, on a pu calculer une hauteur théorique de l'eau atteinte au cours des inondations. En effet, grâce aux coordonnées Lambert obtenues des stations du SPW, on a pu déterminer pour chaque objet de risque de notre portefeuille la station la plus proche. Ensuite, on avait également à disposition chez nous la hauteur de l'objet de risque par rapport à la rivière la plus proche et la distance à celle-ci. L'estimation de la hauteur d'eau a donc été déterminée en prenant la différence entre la hauteur connue à la station SPOE la plus proche de l'objet de risque et la hauteur de cet objet de risque par rapport à la rivière la plus proche. Une fois qu'on a calculé cette hauteur d'eau, on a pu mettre à disposition des visuels qui prenaient en input toutes les données qu'on a récoltées. Ces visuels, ils nous ont pas mal été utiles pour nos analyses. Ils ont également été utilisés par la gestion, nos équipes sur le terrain, les inspecteurs, les experts, mais également d'autres équipes internes chez HEC. On a pu notamment classifier notre portefeuille selon la gravité grâce à la hauteur, en fonction d'une certaine gravité, grâce à la hauteur d'eau calculée précédemment. Donc, comme vous pouvez voir ici dans l'exemple à gauche, on a visualisé tous les objets de risque de notre portefeuille dans la région d'Angleur et les couleurs représentaient la gravité en fonction de la hauteur d'eau estimée. Donc, par exemple, ici, vous voyez que la région avec les points bleus, c'est une région dans laquelle on s'attend à ce que les dégâts attendus soient les plus importants. Et c'est lié forcément à sa localisation entre l'Ourthe et la Meuse. Ce qu'on a fait également à droite, c'est de visualiser parmi tous nos risques objets ceux qui sont déjà sinistrés au cours de temps. Et donc, par exemple, au moment du screenshot là, tous les points en noir, c'était tous nos objets de risque qui avaient déjà été sinistrés. Cette carte, elle a notamment été utilisée beaucoup pour la gestion, puisqu'ils ont pu avoir comme ça une vue d'ensemble géographique des inondations. Ils pouvaient suivre la situation de jour en jour et ils pouvaient également avoir une idée des sinistres encore à venir. Puisque bien évidemment, si par exemple dans une rue il y avait 10 objets de risque couverts et que parmi ces 10-là, il y en avait déjà 9 sinistrés, il y avait de très grandes chances que le 10e arrive dans les prochains jours. Et donc ça les a permis un peu à être proactifs, parce que de là, ils pouvaient par exemple déjà prendre contact avec le courtier pour que celui-ci recontacte le client et voir si effectivement le sinistre devait bel et bien être déclaré. Arrivé à ce stade, on avait donc déjà une bonne vue sur... Pardon. On avait déjà une bonne vue sur les régions les fortement impactées, moyennement impactées et faiblement impactées. En plus de ça, grâce à notre estimation de hauteur d'eau, on pouvait encore subdiviser ces régions en donnant une certaine sévérité, en disant voilà, on estime qu'il y avait 2 mètres d'eau, on estime qu'il y avait 30 cm d'eau, etc. Et donc, pour toutes ces régions et ces sous-catégories qu'on va appeler zones, on a pu envoyer nos experts et nos inspecteurs sur place pour qu'ils puissent nous donner une estimation du coût dans chacune de ces régions et chacune de ces zones-là. Et donc, avec toutes ces informations récoltées, au bout de 2 semaines, on a pu déjà donner une première estimation du coût total. En effet, grâce à ce que Claudia a expliqué, donc la vitesse de déclaration des sinistres, on avait une idée du volume de sinistres attendus. Ces volumes-là, on l'a divisé dans certaines régions. Donc, comme je l'ai mentionné, il y avait les régions fortement touchées, faiblement touchées et moyennement touchées. Et en plus de ça, on a encore subdivisé ces régions selon la sévérité estimée grâce à la hauteur d'eau. Et donc, pour chacune de ces régions et chacune de ces zones, grâce à la contribution des experts et des inspecteurs, on a eu une estimation du coût. Et donc, pour avoir le coût total estimé d'AG, on a multiplié ce volume estimé de sinistres par ce coût déterminé par les experts. Pour le coût engendré d'un point de vue marché, on a alors pris le coût de AG qu'on a multiplié par la part que AG a sur le marché. Pour avoir une idée, après 2 semaines, 2 semaines après l'événement, on avait une estimation du coût de marché qui s'élevait à 2 milliards d'euros, ce qui est encore assez proche de l'estimation que Claudia vous a donnée tantôt, de 2,2 milliards d'euros.
Alors ce premier modèle avait surtout pour but de donner une réponse rapide, et c'est une bonne pratique en fait de notre métier de commencer petit, simple et rapide, et ensuite d'ajouter des informations en fonction du feedback qu'on reçoit et de travailler en itération. Et donc c'est ce qu'on a fait, on a continué à travailler avec les différents spécialistes, les gestionnaires, les inspecteurs, la direction, qui nous ont proposé de nouvelles pistes de recherche, ils ont challengé nos hypothèses, ils nous ont aidé à comprendre ce qui pouvait impacter le coût, ou aussi tout simplement aider à comprendre comment le process de gestion de sinistres se passe. Et on a un deuxième énorme avantage à ce stade, c'est qu'on est déjà un peu plus tard, et donc entre-temps, il y a des sinistres qui ont été déclarés, qui sont rentrés. Les inspecteurs aussi ont pu continuer à faire leur travail, à faire des inspections, et toutes ces données rentrent dans nos systèmes, et c'est là qu'on peut commencer à jouer et à construire un modèle qui est un peu plus data-driven. Rappelez-vous, dans le premier modèle que Mathilde vous a présenté, là on travaillait encore par agrégation. Donc on disait, voilà, on a identifié telle zone, on pense qu'il y aura autant de sinistres avec tel coût moyen, on multiplie tout ça. Mais maintenant, on a des informations beaucoup plus granulaires et jusqu'au niveau sinistre. Parce que pour chaque sinistre qui est entré, on connaît forcément l'adresse, et donc on connaît la sévérité en fonction de la hauteur des eaux estimées. On connaît aussi les couvertures du client, on sait s'il a le bâtiment ou le contenu ou les deux, et ça aussi, ça impacte le coût. On sait aussi, si l'expert a déjà fait sa visite, on connaît son estimation. Et enfin, entre-temps, il y a aussi certains dossiers qui sont déjà clôturés, et pour cela, forcément, on utilise simplement le coût réel. Et donc, toutes ces informations, on les a intégrées dans notre modèle. On a fait des prédictions sur chaque sinistre individuel, et on pourrait un peu résumer ça en fait par un arbre de décision, où on regarde dans un premier temps, est-ce que le sinistre est clôturé? Si oui, on prend le coût réel. S'il est encore en gestion, on va regarder si un inspecteur a fait une évaluation, parce que dans ce cas-là, on va plutôt partir sur l'évaluation de l'expert. Et dans tous les autres cas, on a continué à segmenter, sauf que la différence ici, c'est qu'on a appliqué un coût moyen qui était basé sur les coûts des sinistres qu'on connaissait déjà, donc surtout ceux qui avaient déjà une évaluation ou qui étaient déjà clôturés. Et enfin, il y a un troisième petit groupe tout à droite. Ce sont les sinistres qui ne sont pas encore déclarés, mais qu'on anticipait encore, parce qu'on avait une idée de quel volume final on aurait. Et ce qui est beau dans tout ceci, c'est qu'au fil du temps, à mesure que les gestionnaires traitent les dossiers, que les inspecteurs font leurs inspections, ce modèle en fait se met à jour automatiquement avec les données qui entrent. Et donc on se base de plus en plus sur des données réelles et de moins en moins sur des estimations. Donc on va bientôt passer aux questions-réponses. Mais avant ça, encore un dernier petit mot. Donc avec Mathilde, on essaie de vous montrer l'importance des données pour aider à gérer une crise. On a donné beaucoup de réponses en interne aux équipes d'inspecteurs, à la gestion, à la direction. On a aussi mis sur place des reportings pour que chacun puisse faire son suivi de son côté. Mais on a aussi répondu à des questions qui venaient de l'extérieur, et notamment Assuralia, l'union des assurances, et aussi le gouvernement, qui eux aussi avaient besoin d'évaluer la situation et qui nous ont posé beaucoup de questions, et donc avec qui on a eu pas mal d'échanges. Et pour répondre à toutes ces questions, on peut utiliser des données internes, externes, géographiques, sous toutes ces formes, mais il y a une forme de données qui était vraiment importante, et c'est tout simplement l'input qu'on a reçu des différents spécialistes. Et ça, c'est vraiment quelque chose qu'on a fortement ressenti dans ce projet. C'est l'importance, en fait, de l'expérience du terrain, et ça, c'était pas à négliger. Voilà.
Do we have questions from the audience? Les questions de l'audience? I think there are questions. Yeah.
J'étais curieux de savoir sur quel type d'outlier vous êtes tombé au niveau de dans votre cas justement.
Il faut juste, s'il vous plaît, répéter la question dans les micros pour ceux qui sont en ligne.
Vas-y, si tu allais commencer.
Donc la question, je vais juste répéter.
Ah oui, d'accord.
Donc la question était quel type d'outliers vous avez rencontré dans votre étude?
Bah, pour ceux qui avaient déjà une réserve, on a tout simplement pris le montant qui était estimé par l'expert et on n'a pas traité les sinistres différemment que dans toute autre circonstance. Donc si c'était effectivement un gros dégât, c'est simplement ça qu'on a remboursé. Ou est-ce que tu voulais dire pour les estimations des coûts moyens?
On a une grosse différence entre l'estimation versus ce que l'inspecteur nous donne par exemple comme chiffre. Est-ce que ça a été un peu analysé, voir pourquoi justement on avait cette discrepancy entre les deux?
Tu voulais peut-être parler du capping, ah oui.
Ah ouais, c'est ça. Mais je pense que c'était ça. Non, parce que du coup, quand... tu peux répéter la question? J'allais répondre à la première. Oui. Et donc, il a demandé comment... Oui, s'il y avait une différence entre notre estimation et l'estimation des experts, est-ce qu'on a analysé ces dossiers-là? Donc effectivement, au cours du temps, quand notre modèle a évolué et qu'on regardait vraiment sinistre par sinistre et que, comme Claudia l'a dit, quand on avait des informations des experts, qu'on a mis ça à disposition dans le modèle, il y a eu toute une phase d'analyse où on voulait aller voir les différences entre. Bien évidemment, parfois, je reviens sur ta première question avec les outliers, on a la majorité des cas, c'est des maisons, des bâtiments, des appartements, mais on peut aussi couvrir des grosses surfaces commerciales, etc. Donc, ce type de bâtiment, oui, ça va avoir tendance à augmenter ou diminuer ton coût moyen. Il faut les retirer de nos analyses et typiquement, ce genre de truc est revenu après dans nos analyses où ils ont été sur place. L'expert a donné un montant par rapport au bâtiment qui était couvert, mais donc ça ne matchait peut-être pas avec notre estimation parce que c'était une grande superficie commerciale ou ce genre de choses. Mais oui, on a eu ça, on a analysé ça.
Donc moi j'avais juste une question, mais par rapport, à voir si vous aviez une vue sur la qualité des prédictions de votre modèle au départ, c'est-à-dire que vous avez un modèle donc qui allait se baser sur la montée des eaux pour voir si une maison en fonction de son élévation par rapport au niveau normal allait être sinistrée ou pas, et éventuellement à quel point elle allait être sinistrée. Est-ce que ça vous avez une vue sur, à partir de simplement ces données-là, à quel point vous avez été précis sur sur des prédictions? Est-ce que vous avez un énorme pourcentage de maisons qui ont effectivement été sinistrées et qui devaient l'être, etc.
Oui, on a gardé une trace de tout ça et effectivement les listings qu'on envoyait à la gestion, après on pouvait facilement voir si effectivement les sinistres ont bien été rentrés dans le système. Donc oui, et on identifiait forcément des régions les plus sinistrées. Donc oui, on avait des bonnes conversions après suite à nos fichiers. Oui.
Data source que vous n'avez pas utilisé pour le départ, mais qu'à refaire vous utiliseriez maintenant en fait, qui aurait pu être justement plus prédictif, qui aurait été disponible, mais que vous n'étiez pas forcément au courant, ou ce genre de choses?
En réfléchissant après, oui, par exemple, on aurait pu utiliser la quantité de précipitation, on aurait pu regarder les débits de l'eau. Tout ça aurait pu encore être un peu plus précis pour savoir vraiment les dégâts, puisque si tu as des eaux montantes simplement ou des eaux descendantes, ça n'aura pas du tout le même impact sur ton sinistre. Ouais.
Et d'autres éventuellement données open data ou autres, je sais pas, qu'est-ce que vous aviez à dispo et qu'est-ce que vous auriez pu encore utiliser en plus, mais... Ok, merci.
Oui.
So our next speakers actually are from We Group, and they will explain to us how to automate the claims process using AI, I suppose.
My name is Björn Velsteker. I'm CPO and co-founder at We Group, and we're an insurtech company from Ghent. So we've had a long drive coming here. What's my background? Well, my background's in computer science. So although I'm in product mainly at the moment, for me, I've always been passionate about innovation and digitization as a whole. Normally, in We Group, we provide a pre-sales sales platform for insurance brokers and intermediaries, which we do for brokers in Europe. But today I'm going to tell you about one special client where we had a journey towards automating claims processes. Probably many of you know DEKRA, but for those who don't know DEKRA, DEKRA is actually a global expertise concern. In 2019, they had more than 3.5 billion euros of revenue. They're active in more than 60 countries and over 5 continents, and they have a huge focus on claims processing and expertise. So in Belgium, they have 4 offices. That's in Zaventem, Antwerpen, Ghent, and Charleroi. And they actually reached out to us a couple of years ago to help them automate their claims processes. Now, at that point, they actually had a very simple process, right? Started out with an email coming in from the insurance company. Next, the email was handled a couple of days later, maybe, depending on the workload, by the claim handlers. Took about 15 to 20 minutes. Next, it was taken over by the expertise team who needed to plan it in. And then afterwards, the expertise was actually executed, where even follow-up was needed. So a very simple process, however, very manually. The question was, how do we make this as a straight-through processing workflow? Well, the first thing is we identified their challenges, right? So the first thing is they have a very variable data structure over different companies and emails. What does that mean? Well, they actually handle claims from different insurance companies, many independent or direct ones in Belgium, but every insurance company uses their own documents, their own forms, their own ways of submitting. They forward mails in threads, they dump mails in PDFs. Sometimes they lose documents, they scan it, but it isn't clear. So it's very rough data. The data quality, like I said, is also not ensured from the input side. We don't know if data is coming along, if certain fields are filled in, but still they require us to get all the information out of it. There's a low technical capacity, but there's a high technical request. What do we mean by that? Internally, they have a very small technical team that's supporting their API, for example. However, there are many stakeholders involved into this process, and those stakeholders also need to get their share of the technical capacity. So they wanted to look for a partner who could outsource as much as possible from their operations. And last but not least, there's of course a huge inefficiency in their manual labor, because those 15 to 20 minutes mostly go just to searching through the documents and typing over things in their own platform. So the question is, how can we make this better and at the same time also scalable? We just had a talk about the floods. Huge amounts of claims come in that moment, but they're also not equipped to handle that. So how can we actually make their operations more scalable so they're also equipped to handle more of those natural disasters? Well, we actually solved it in a certain way. It's a flowchart. I'll take you to it right quickly, and then we'll go more into depth. So the email is coming from the insurance company. We're actually taking it into our account, which is just an SMTP server, taking in the emails which are forwarded to us. At that point in time, the first thing that we do is actually extract the data from the email, so the data and the metadata and all the textual information. We put that aside, and then we actually take out all the documents. From those documents, we put them through a classifier, which simply states, okay, this is an image, this is actually a policy, but we also split the documents, right? Because sometimes they scan in everything into one PDF document, sometimes multiple things are available on one page. So we actually take in all the different pages, we go to put them through a classifier, and we say, this is a policy page, this is a page from an invoice, this is a page from, and so on and so forth. Once we've identified certain categories, we can actually then apply certain next steps. For example, if it's an invoice, you want to use OCR to extract that information. If it's a policy, you want to extract other information, and so on. At that point, we actually put everything together in the API call, but not before putting everything into a multi-model classifier, which I will get to in a second. Now, like I said, there are different data types, right? We have images, which aren't really clear. We have many pages, which is just plain data types. And we have JSONs coming from metadata from our emails. Now, how can we actually put everything together? Well, first of all, we have the document classification. That's an easy one, right? Everybody knows document classification. It's not necessarily rocket science anymore. So that's an easy one to train with not that many samples. We can put it through it. And we actually have a proper, decent document classifier. Then we have the OCR. The OCR gets a little bit more tricky depending on what invoices you have. Certain invoices are written by hand. Yeah, that's a difficult one, of course. But luckily, most of them are actually gone from real persons who actually extract them from the CRM systems. Even though they are scanned, we're still able to get out the total amounts, which then goes towards estimating the total value of the claim. Entity extraction, depending on the documents that are submitted. For example, the question to expertise, type of expertise, contact person, policy number are all things we needed to extract, and they also are very dependent on the documents. So for some of them, we use rehexes, actually for most of them, because those are the most stable. For others, we train some models. And then comes the tricky part, the image classification. It's not necessarily that we need to detect what's in the images. We need to use that information to get to the most difficult part of the claim, and that is, what damage type are we talking about here? Is it a water claim? Has it been a storm claim? Are we talking about fire here? Are we talking about other things? Like, how can we actually discern that from the information that we gathered? That was for us the most tricky part. Well, first of all, we actually used all the images and we looked at them from a data science perspective. So we built a data set with 2,243 images from over 500 emails, but there was a high imbalance. As you know, most of them were to water damage, other damage types, a little bit less to storm, but for example, relating to theft or glass breakage, there were almost no claims submitted. So first thing that you do when you're in data science, you balance out the data set. We used many different things such as horizontal and vertical flips, zooms, rotations, widths, and height shifts to just make sure that we have sufficient data which is balanced to use in our model. Next, we applied an image classification with an efficient net B4. It's a CNN, which is one that actually works well with a few data points. The interesting thing is here, it's actually a model that is used to train detection. So detection of objects, for example, we used certain layers at the beginning that were already pre-trained, such as ImageNet, for example. So those were able to detect images, but instead what we did was go towards that classification. At the end, we actually had the embeddings from the last layer, which were over 1,700 different dimensions, and we actually reduced them using neighborhood component analysis to only 3 dimensions. And this is my favorite GIF. You can very clearly see in those 3 dimensions that there's a clear discrepancy between the different data types detected in the images. So that's already a good start. Now, we actually have lots of information that we didn't use yet, right? We have, for example, JSON data, or all the data that is coming just from textual files. So for example, different data types, file names, and everything. We also use that to go into one decoding with simple 2 dimensions. And we use those with NCA again, where we can see that there's, although a little bit more difficult to detect, a clearer dissertation here between the different data types. We put everything together in a multi-model classifier, and we trained it end-to-end with only a few epochs. We don't have giant big servers to train on, so it was very hard for us to train. But at the same time, doing it end-to-end really solved the problem of getting those embeddings learned up as well. So for the text classification, for example, we used the BERT model to transfer the textual knowledge into those word embeddings. Why did we use BERT? Because it works really well for the Dutch model, but also for French, for example. And as we're in Belgium, we need to support both in terms of the documents. At the end, we had the 12 possible damage type categories, and on the model that we've trained, we had a 77% of accuracy on the validation set and a 75% of accuracy on our test set, which was really amazing. If you think about the random one, then it would only be like 8%, as we have 12 possible damage types. So that's a huge accomplishment. Now, actually going forward over the years, we of course iterated on this. We had more data, more feedback, and for the different things that we detected, we actually got up our damage type a little bit more. Like you see in the practice, now it's only 67%. It was on a test set, so that's only logical. Other things that we're detecting, as we're seeing as KPIs, are for example the case type, broker matching, so a matching of the broker that's inside their system, making sure that that's matched properly, the name of the policyholder, subcase type, and assignment types. Why are all these things important? Well, of course, they are normally spending 15 to 20 minutes per case, but with our case, we actually get them through the system and we submit it and they just have to review it. So reviewing only takes about 5 minutes. That's a huge gain. That's about 60-70% time gain. However, every case that they need to have work on, so every case that isn't accurate as a whole, needs some more manual labor. So that leads up to those 15 minutes again. So the more accurate we are as a total product towards the submitting the information, the more time they save and the more resources they have available to work upon other things. Now that was actually the first part. Then in came the second part, the expertise planner. So that was a really interesting one because there they didn't go for time saving. They did go for load balancing and very high efficiency. So for example, things that they weren't taking into account into their manual planning was, for example, traffic conjunction, because they couldn't predict that. They were just thinking, oh, if the person has to go from Ghent to Antwerp, that is about maybe 1 hour on average at that hour, because they knew that from expertise. If a new person started, that new person didn't have that information, and still it was really just random. Lots of planning needed to happen, which was very inefficient for manual handling. That actually meant that load balancing was really ineffective. Sometimes there was one expert who didn't have anything on his agenda, and other experts which had like 3 weeks fully booked. So it couldn't be like that. It needed some load balancing. And also every expert has his own needs and wishes, which is just really difficult to take into account when you have to plan them in manually. So how did we fix this? Well, we actually started out with time slot generation. So we coupled in all the calendars of these experts. We then checked, okay, where were they previously? Where did they have to go to the next point? What time slot was available? And could they go from A to B, from B to C, and spend enough time there to execute their expertise? Would that fit in their calendar? If it would fit, that would mean, yes, we have a time slot. With the time slot generation for the different experts that were there for about 2 weeks up front, and then we actually proposed them. We proposed them up front and said, like, look, these are the different slots you could choose. At first, we just let them choose from the slots, and of course, some slots were like the 30th slot, the 40th slot, but in that way, we could have some data generation. We could have some real data, knowing like what slots are you picking and why. But the why wasn't really important because we had the data, what slots are you picking, and what slots obviously aren't you picking. With that information, we built a training set with over 10,000 samples, where we knew 1 of which was picked and 9 which weren't picked. And then we actually just did a simple logistic regression to actually train those to predict which one should be picked. At the end, we saw that from our sets, actually, most had, if you would give them the score and you would rank them, the one with the highest score would be like the 0th slot, then the one with the fewer score would be the first slot, and so on and so forth. So that means that for the person opening their application, they get 5 slots proposed to them. Well, the first 5 slots would be those who they would choose the most. So it would save them time again. At the first, we had lots of filtering because they had rule in place. For example, oh, if it's more than 45 minutes away, you can't do this. And as they were using the system more and more, we actually cut the rules because they saw that they would have that they could put more trust in the system instead of like hard rules which would oppose some issue zone later. The feedback actually was that they are now using the scheduler exclusively because they see that the load balancing is very active, and if they don't use it, it won't be balanced again. And that they have built, together with us, a customer scheduler, like a sort of doodling system which they can just send towards the customer, and the customer gets those proposed slots which are generated automatically, and the customer can just choose which slot works for them. So again, a huge time saving on their end. Just show you how it works. This is actually for their back office. They can just put in all the information. They can actually select, sort, whatever that they want. We automatically get the information from the claim from their backend side, from their CRM system, and then we actually generate these slots. For example, for this expert, it says it's a 30-minute drive. He can do the expert from 9 till 10:15, and then there's the next drive to his next appointment. So that's why it would be helpful for him to be planned in there, because it would be on his way to the next client. And on the customer side, it's just a very simple, elegant doodle-like system where they can just select time slots, which, if selected, will already be directly booked into the agendas of the experts. So that's actually how we did our journey towards claim automation for DEKRA. And if you have any questions, I'll be happy to answer them.
on the floor. We have time for 2 short questions.
What was the reaction of the expert?
Very interesting question. The reaction of the expert was actually in the beginning negative, but while time progressed, more positive. At the beginning, the issue was that experts always had their their needs were more taken into account by the certain persons that were planning them, because they knew, for example, that person didn't want to drive that far ahead. So they always planned around their region, and they actually always started out from where does that person live, and that person needs to go to there, back, to there and back, to there and back. So they were always thinking in ranges. And people are also thinking in ranges. If, for example, you would say to an expert, you have to go 10 kilometers to there, and then the next one is about 5 kilometers from your house, but you have to drive like this and this and this. For them, in their heads, it would be more feasible, because they would see like, oh, but that's all about, that's all in my range, so that's okay. When you get for a route, now you start at your house, you have to drive there, and back again. Like, some expertises are really outside of your range, which they normally do, but it's way more effective because you can do a full circle, you can avoid traffic congestion and things like that. So for them, it was an adoption, a real adjustment, but now they're happy with it.
Are you using a feedback loop from your expert?
Yes, we are. So what I said is actually we are putting everything through our system, putting it into their API, and the claim handlers, which instead of putting 15 to 20 minutes work in, they're actually just putting in 5 minutes of work to check it. So they go over all the fields, they see, is this field filled in properly? Is it the correct one? They just have to check it against the documents, but they don't have to type it over, they don't have to search it. It's all there. If they then, for example, change things, or they have to get more information from some clients, then they change it in the system, and once they submit it towards planning, once it's finalized, we actually get a notification through webhooks where we get the information again. Then in our end, with our BI platform, we actually just put them next to each other. That's actually how we calculate these accuracies. We actually just we just check what we put against their system and what they have checked to be true or false. And that's actually how we get that feedback loop.
No, I was just wondering about two things. One, what was your subclass accuracy? Like each class, since you're trying to classify 12 classes, if I remember correctly. And the second question was mostly about the model, the combination of all the features.
That's a good question. Actually, I don't really recall. This model was set up in 2019. Since then, we've been tweaking a lot. So like that way in depth, I can't answer. Sorry.
About the feature, where you combine all the features to feed in the model. Did you guys test that, like increasing, decreasing feature?
Yes, we did different things. The thing that we most did actually was at that point, like before the multi-model, was just work on the images. So just start with the image set, see where the accuracy went from there. But we saw that every time that we used the multi-model and that we went more towards the multi-model, always relevant information came in. So in that way, the accuracy was always higher. However, the thing was that it still needed to be performant. So that's why we applied lots of dimensionality reduction. Although we lost lots of information, it really helped speed up the process and speed up the training as well, which for us was a bottleneck with the data that we were dealing with.
Was it fight for precision or recall in your case, or it was just total accuracy?
For us, it was more on precision. Yeah, more on precision. Because for them to, for example, sketch out, if, for example, we would get out the information and we would say, for example, okay, the zip code of the address where you need to go is, for example, 8,000. But instead of an 8, it was a 2. So it's, for example, 2,000. That means that the expert is driving towards a certain house in a whole other region in Belgium. He would be there, like ring the door, and they would be like, it's not here. But at that point, somebody else is waiting like an hour drive away while that person isn't coming along. So that's a very important one. The data that has to be submitted needs to be really, really accurate. It's better sometimes to not submit the data instead of submitting wrong data. That's why we always had to check addresses against their own data, against databases and matching, while the brokers in the system, for example, we just couldn't put in the broker name. We had to check against the entities in their system and validate, okay, is this a broker that exists? If not, how can we actually tackle this? So lots of verifications, yeah.
Do you have an idea of how trade-off is between the time the trade-off between the time gain versus the accuracy loss or the precision loss?
On
the trade-off between how much time you gain and the accuracy drop.
I think for most things it was marginal up to this point, because the fact that we got up to this point of accuracy was also because most of the other ones were just very, very odd edge cases. For example, we always had to take into account the human error as well. We did one session where we actually checked out the human error, and the human error was in most cases of the KPIs that we were tracking bigger than the accuracies that we were providing. For example, for broker matching, I know we did a test on a manual test on 200 cases where we ran them through our program, and we had about a 95% accuracy. But at the same time, when we actually checked the values that the claims handlers had put in against the documents ourselves, we saw that it was about 90% accuracy. So our model was actually outperforming the human error at that point. So in that way, there wasn't really need for optimizing more, as we had like we could lower the accuracy, or we could keep the accuracy and like the same speed that we had, but we didn't have to improve more for that way.
All right, thank you very much.
Okay, super.
He has many difficult questions, but I think you can keep his difficult questions for the drink session here.
We'll talk afterwards.
Thank you very much. We will now welcome our guest from KPMG, Lana Coury and Dieter Putzeis. The floor is yours.
Good evening, everybody. My name is Dieter Putzeis. I'm a director at KPMG Luxembourg, responsible for the insurance sector at advisory level. I've spent most of my career in Luxembourg and in the insurance sector, so I have a background in life insurance. And today we're going to talk about, of course, the ecosystem around insurance companies. We've already had two very interesting discussions and presentations, and they were both on very specific use cases for data in the insurance sector. What my colleague Lana and myself are going to do, we're going to take one step back. We're going to explain a bit from a macro standpoint why insurance companies start this journey and what are they actually trying to accomplish. And most of it is driven by customer experience and using the data that they have. Insurance companies are very data rich, but they don't always use it. And there's a huge potential in there.
So some of the main influences that we see driving this evolution actually for insurance companies is here. So as Dieter mentioned, insurance companies are data rich, but traditionally haven't made use of the data or made the most use of the data in the past. Particularly when it comes to driving sales, supporting the sales channels, and also providing insights to their intermediaries. But we see change thanks to two global trends taking place. As Dieter mentioned, the increased focus on the customer, and also the explosion of data that's currently being collected. So this is allowing, a lot of insights for insurers to have. A big drive is through data science, obviously, and artificial intelligence, which we believe will have a profound impact on the landscape of insurance over the coming decades, which we're going to give you a bit of an insight, hopefully, to this evening.
So thanks, Lana. So what if you compare the insurance companies of today to the past? In the past, insurance companies were just having clients having a risk, and they would like to cover that risk. If you have a claim, the insurance companies would pay. So what we see now on the market is a shift towards an insurance ecosystem where insurance companies team up with different companies, insurance companies or not, to bring value to the customer. Because in the past, if you would have think about an insurance company, probably you would think negative things. Because when do you contact your insurance company? It's to pay a premium, which is mostly negative because most people don't like paying insurance premium. Or when you have a claim. And when you have a claim, depending on the type of claim, of course, it's pretty negative as well. And then people worrying about, will the insurance company actually pay me something? Yes or no? Is my risk covered? And so on. What we see now is insurance companies moving to a different model with more touch points with their clients, in the sense that they're actually pushing their clients into a direction, in the sense that they're trying to prevent certain things. It's not only about paying out, it's about preventing as well. It's how can we help our customers have a better life. This is a very, very shift in the insurance world, and not everybody's ready for that. Because I was having a discussion yesterday with an insurance company in Luxembourg, it was AXA, and what they have been doing lately is they're publishing on Twitter if there is a storm coming. Please put your car inside because the car might get damaged and so on. And what was actually really interesting to see is that some clients really like that. Oh, my insurance company is really taking care of me, they're trying to prevent certain things. And other clients are saying, it's my personal life. I don't want the insurance company to interfere with that. And they ask themselves, what if I don't put my car in my garage? Will they actually pay my claim if something falls on my car? So we see lots of things happening on the market. Clients reacting differently, everybody's different. But this shift is quite important. And I think that's also the way to go. Because if you look at different markets in the US, in Asia and so on, they're miles ahead of us. And they're really into that prevention part of the game. They're really into how can I help make the life better of my clients, and how can we together accomplish a goal. It's not only about insurance. Insurance is actually on the background at that moment. It's really about working together, about making their lives better.
So historically, insurers have provided products based on customer risk profiles. Here we talk about connected insurance and connected ecosystems, which sees the insurers needing to take one step further in their journey and actually think about focusing on the customer's lifestyle instead. Because we see three core areas where connected insurance will have their biggest evolution. It's within the health, home, and transportation area of the customer's life. So you can see here the different touch points of the connected ecosystem. We also include travel and, as Dieter mentioned earlier, the life events. What is really important for insurers that are looking to pursue this approach is that they first focus on specific customer segments. Then they look to focusing on the customer type itself. And that will then enable them to be able to actually then bring the right connections across the ecosystem. Why is this important? Because we see the role of the insurer evolving from what Dieter alluded to in the beginning, which is being the kind of intermediary, I would say, the middleman when something goes wrong and the customer needs to put in a claim, to being a full service customer concierge, in fact. So playing a really important role in the entire life stages of the customer's life. So I'm going to give you some concrete examples of how this is working in the Asia Pacific region. So my mum lives in Australia, She's a 70-year-old woman, super fit. She goes to the gym 4 days a week, really into tech. So she's got her Apple Watch. It's connected to her health insurer's mobile app called Medibank Live Better. And all of her movements are tracked all day long, even while she's sleeping. Every night it gets uploaded, the data gets uploaded into the health insurer's app, and she gets credits in the form of vouchers, which she can use to pay off her premiums. She can buy trainers, she can buy gym clothes, or anything that from an online store or in a shop that any of the partners in her health insurer's ecosystem offer. So this isn't new in the Asia Pacific region. This has been going on already for a couple of years now. They are exploiting every bit of data that they can get their hands on in a positive way to help their customers. Last month, over the summer, she was here, and I had a conversation with her about the fact that she's sharing such confidential personal data. I mean, these apps are tracking everything. And her response was pretty clear and pretty cool, I would say, pretty progressive. She said to me, well, I share so much of my life and information on social media. At least with my insurer, I'm getting something out of it. We were a bit debating, like in EMEA over the last, I'd say 5 years, you can find a lot of surveys online from the Big Fours around the topic of people sharing personal data for health, home, and auto insurance. And we do see a steady increase on people's willingness for two reasons. If they can have more accurate premiums, which the lady spoke about earlier, and also benefits. But we do still see challenges for insurers when it comes to having trust. So customers having trust that their data will be used ethically and it'll be stored securely. So there are a few other examples. Like I think it was about 6 years ago, I was working with a car leasing company in Belgium, and they were in the early stages of testing out driver behavior using telematics. It didn't go so far in the end. We had a successful proof of concept, but they were blocked with limitations of people being willing to share their personal data, but also the technology of telematics was not so advanced back then. But gyrometrics now these days in smartphones are pretty good. So we do think that the hurdle will be, as with most industries, trust in the data and the company and how it's used.
And then here on the screen, I'm not going to go through every one of them. There are a couple examples of insurance companies really trying this. So it's mostly about trial and error. They do small projects, they check if it works. If it doesn't work, they move on. But at least they're trying. And as you can see, you have many international companies here. I have a very small example that was used in Luxembourg a couple of years ago. It was Baloise that used a game actually to test. It was called a Game of Roads. So everybody had an application on their smartphone, and you can use it when you're driving. And then at the end of your drive, you would get like a score. And there you could see that it's really hard. I tried it, and every time you were speeding or taking a corner very fast, it would like decrease the points. So they didn't really do anything with it in the end, because you have to know that Luxembourg is a very small market, and to really launch a product like that, it would be very costly. But they're thinking about it, and I think that's the way to go. And as Lana was saying as well, technology is changing every day. So technology is becoming very accurate. At one point, everybody will have a chip in their car, and then at some point you won't have a choice anymore. That's basically what Tesla is doing as well. And Tesla, and I know that is thinking about launching an insurance company in Europe, because they have all the data. And when you buy a Tesla, you probably sign I don't have a Tesla, I don't know, but you probably sign a paper, you sign a waiver, and they can use your data. So this is a little bit even beyond connected ecosystems. So we have a couple of focus areas that we want to explain you here. Of course, distribution is a very, very hot topic. in the past, distribution was very traditional. You would go to an agent, you would go to a broker, you would explain a bit what your needs were, and that person would propose you a type of product, a type of contract, and so on. But nowadays, based on your data, you can actually get products that are fully in line with what you need, fully in line with your lifestyle, and based on your behavior as well, as we explained before. So in the future, products will become very much aligned with yourself, which is a very big shift as well from the past, because in the past, what did insurance companies do? They would pool a certain number of risks. And that's how people would be having very risky behavior, and most people would be having very normal behavior. And then in the end, they would be able to pay claims because they had a big pile of money, because everybody would pay their premium. What we see in the future happening is that premiums will be tailor-made, which of course, and then it's an ethical question, what will happen to the people that have very risky behavior? Will they still be able to find an insurance company, an insurance cover, yes or no? I don't have the answer today, but that's one of the questions we can ask ourselves. It's also about insuring cars that don't have a steering wheel anymore. If you have an accident, whose fault is it? It's, of course, it's very questions that don't necessarily have an answer, but that's what insurance companies nowadays are thinking about. Of course, underwriting is a big part of it, and I already touched a bit on this. How will the underwriting process change? I think it will change dramatically, because based on data, you can really fine-tune your underwriting process, and you can really propose to your clients a premium that is based on real data instead of estimations. Of course, you will still have estimations, but you will fine-tune it to a point where your premium is going to be very precise and very much in line with the risk profile of each client.
And I think interestingly here as well, when it comes to the ecosystem, is the new role of regulators and the increased hands-on, I would say, aspect to their role in terms of reviewing AI-enabled and machine learning-based models. Because and a bit linked to what we said earlier, the increased request of transparency and traceability of the scores is going to have a big impact in how this technology and the evolution of the business models will be adopted. And maybe lastly on claims. So here, and this might upset some insurers by me saying it, but we see that so the claims processing will still remain a primary function of carriers, but more than half of the claims activities will be automated. So the shift in focus will be around for humans at least, and human claim management is going to be more based around complex and unusual claims that the models are still learning to be able to ascertain. Contested claims as well, and any claims that are linked to systemic issues of new technology being introduced into the ecosystem. So we've spoken a lot. We've taken a very big step back to the first two presentations, but hopefully you could see that data science, big data, artificial intelligence, machine learning is really critical to all of this, and really necessary to consider for insurers that want to follow in the footsteps of HEC Insurance, to consider along their journey. And the biggest thing that we see in these cases that have been successful and working with clients is that it all really starts by asking the relevant questions, then being able to have the right understanding and defining objectives for a given problem, and building upon it from there. So we're happy to answer any questions if you have any.
Question for anyone? Yes.
Well, the problem that we see in Europe regarding legislators is that every country is still different. We don't have a single market like you have in the US, for instance. And every country has specific rules, even though lots of regulations nowadays come from Europe, come from EIOPA and so on. Every country will have their different accents and so on. So that's really not helping all of this. And if you look at, we have really big European insurance companies like AXA, Allianz and so on. They could decide tomorrow we're going to start using a European model. We're going to implement it in every country. But it's not as simple as that, because then you have to take care of every single country and every single regulator as well. Are they willing to go with us, or are they just going to say no? And I know a lot of examples of European regulators where they're not flexible at all. And they don't want to have all these changes, because if you start implementing all these changes, they will have to check certain things as well, and they're not ready for that because they don't have the capacity, they don't have the knowledge, or they simply don't want to.
Any more questions?
Taking into account the regulation,
Mm-hmm.
what kind of data are available right now that the insurers don't use it, but they could use it regarding the regulation?
What we see, especially in non-life, is data around fraud, for instance. They could start pooling all the claims, all the insurance companies. They will have to work together, of course, and they can identify claims that are fraudulent, because it's the same claim that is sent to various insurance companies. That is something they can perfectly do today. But what we see as well in the market is that insurance companies are still using very old systems and very different systems in parallel as well. So they don't really aggregate all the data, so they cannot do it today.
And it's okay with the regulation if they compile all their claims together, for example? Is there nothing that's...
Well, the big advantage in non-life insurance is that you have annual premiums. So you can change your general terms and conditions every year, and the client signs. In life insurance, and that's a big issue in Luxembourg, for instance, we have very old contracts and you cannot change them that easily. So if you want to implement something new, you have to have the consent and the permission of every single client. And there's always somebody that doesn't want to sign. So you cannot have two operational models in parallel. But in non-life insurance, it's easier. Of course, you still have to do certain changes. You cannot just do it like that, because you have GDPR, you have specific rules and so on. So you need to take those rules into account. You cannot do whatever you want.
All right, thank you very much for your very insightful.
You're very welcome.
And the audience for the questions and their attention. Before we head up for the drink, I would like to invite you already to our next meetup on the 14th of December 2022. As usual, we would have a hybrid session online and on premise. On the online channel, you can log into our YouTube page later on to revisit all the talks that have been given to you today. And subsequently, all the future meetups will be recorded, and you can also have access to all the previous meetups session. That being said, I would like to thank you again for your attention and for your presentation. And I would now like to invite you for a drink, and I wish you a very great evening ahead. Thank you very much. Have fun. All right.